Your AI can design a skyscraper in 2 seconds, but it just destroyed $5,000. Why? Because it has a genius level brain, but zero muscle memory. Today, we will use this brain at right place. In this video, we are gonna understand how to make robots less robotic. Then we are gonna decode the 4 things that you need to actually ship a product. First, giving your AI 3D sight. Second, stopping the vibrations. Third, finding the perfect step size. And fourth, getting supercomputer power onto a tiny chip. So let's get into it. We have all seen the videos, humanoids doing backflips and making lattes. But if you have actually tried to build one, you know the truth. Most AI-based hardware today acts like it's drunk. It's called the impedance mismatch. You have got a brilliant brain in the cloud, but it can't figure out how to pick up a slightly tilted mug. We are still building robots the old way. One program to see, one to think, and one to move. We want physical intuition. Today I'm going to show you the architecture that makes that possible. VLA, or Vision Language Action. In the old way, the eyes send a description to the brain, which sends a coordinate to the muscles. It fails for 2 reasons. First, if the vision is off even by 1%, the system crashes. The world is full of consumers. This channel is for the curious creators like yourself. If you want to build wealth and products instead of just watching, join the elite. Hit subscribe, let's build together. Second, the 10 Hz versus 1000 Hz problem. Your AI brain thinks 10 times a second, but a motor needs instructions 1000 times a second. This creates latency, a fancy word for delay, which leads to that jittery movement. That's where VLA comes in. It doesn't translate pixels into words. It treats pixels and movements as the same language. The secret is action tokenization. Just like ChatGPT predicts the next word, VLA predicts the next centimeter of the movement. But to ship a product, we have to solve 4 deep engineering bottlenecks. Most AI is trained on flat internet photos. If your robot only sees in 2D, it's basically trying to grab a shadow. To fix this, you need depth-aware encoders. You have to feed the AI X, Y, and Z coordinates. It's the difference between looking at a photo of a mountain and actually standing on the edge of a cliff. If your robot starts vibrating, its nerves are lagging. By the time the AI feels the arm has moved, it has already moved too far. We solve this with a low-pass filter. Think of it as a digital shock absorber. It smooths out the noise so the AI's intent and the motor's movements stay in sync. How small is one step for your robot? This is action binning. If your bins or steps are too large, the robot is clumsy. If they are too small, the AI gets overwhelmed. You are looking for the optimal quantization, the sweet spot where movement is smooth but the code stays light. A massive VLA brain is too slow to run locally on a small robot. We solve this using speculative decoding. You run a tiny fast model on the hardware for instant reflexes, while the big VLA brain stays in the cloud and sends corrections every few milliseconds. The result? You move from a scripted machine to a living machine. By solving the latency and the spatial bias problems, you have built something with physical intuition. You aren't just writing code anymore. You are building the central nervous system of the future. Stay curious.